Hello and thank you for joining. My name is Travis Roberts. I'm a cloud infrastructure architect at RBA Consulting in Wayzata, Minnesota. I also blog at Ciraltos.com and maintain a YouTube channel on different Azure topics, including Windows Virtual Desktop. The common theme for this presentation is how to use Azure services to extend functionality of Windows Virtual Desktop. We'll start with a solution available from Microsoft that starts and stops Windows Virtual Desktop Session Host based on end-user load. This solution uses Azure Automation and Logic Apps to schedule a runbook that pulls information from the host pool and starts and stops Session Host based on parameters we specify in the solution. After that, we look at another solution for monitoring Windows Virtual Desktop. It uses diagnostic settings and the Log Analytics agent to collect data on the environment. Both solutions use Log Analytics to track and store data. Let's take a closer look at Session Host and autoscaling. Windows Virtual Desktop has a compelling value proposition. It can scale virtually limitlessly without the associated capital expenses that would be required to scale on premises. User sessions are hosted on Azure virtual machines, and those have the advantage of only accumulating a charge when they're running. So scaling needs to work in both directions. We need to scale up when demand increases and scale the session host down when demand decreases. After all, what good is avoiding capital expenses by moving to the cloud if those expenses simply shift to monthly operating costs? This brings us to autoscaling. Autoscaling in Windows Virtual Desktop provides the ability to power on and off servers based on the number of user sessions and the time of day. The goal is to provide the best user experience possible for end users while minimizing the number of servers running and, by extension, the cost to run them. Today, we go over an autoscale solution available from the Windows Virtual Desktop documentation. It uses a peak time window to start session hosts as users log in. It calculates the number of session hosts to start based on parameters passed to the solution at runtime. The solution shuts down servers outside of peak time. There's an option to force users to log off, and another that's a little less aggressive. It waits for users to log off before shutting down. At the heart of this solution is the Azure Automation Runbook. Azure Automation provides a serverless platform to run scripts called runbooks. Runbooks support multiple scripting languages. This solution uses PowerShell. Runbooks start and stop based on a schedule or by a webhook. A webhook is a unique URL that we can use to trigger the runbook at start, passing parameters in the body of the message. The autoscale runbook does the work of getting information about the environment and starting and stopping session hosts based on the parameters passed to it. An Azure Logic App is used as a trigger for the runbook. Logic App is another serverless automation solution available in Azure. It provides a code or a designer interface with a graphical representation of the processing flow. Speaking of flow, or I guess it's called Power Automate now, Logic Apps and Power Automate provide similar functionality. Only Power Automate is tied to user and an O365 license, while Logic App is priced on a consumption-based model. The Logic App starts the runbook by a webhook, passing the parameters such as start and end peak time and the number of sessions per CPU. When the runbook starts, it gathers information on the host pool, such as the status of the session host and the number of sessions in each. It uses that information along with parameters passed to it by the Logic App to determine if it should start or stop session host. We also have the option to log all the data about the job to a Log Analytics Workspace for us to query later. Log Analytics is part of Azure Monitor. Log Analytics is a cloud-based log collection service. It collects logs and performance data from Windows and Linux servers, as well as from scripts and other sources using the Data Collector API. Next, let's see how this solution is deployed and what kind of data we can get from the jobs in Log Analytics. Here I am in VS Code. To get started, let's make sure I'm logged into Azure. I'll run get az context. And I'm logged in. Logging in should go without saying, but one thing to note, I sometimes use an external Outlook.com account for administrating my subscriptions. That won't work for this. The script pulls some information about the account context, and the Outlook account didn't work. You may have noticed I'm using my onmicrosoft.com account for this. Once we're logged in, the next thing we need to do is create a log analytics workspace. This is needed for my examples coming up. The script on the screen will create the resource group if it's not already there and create a new workspace. Let's run it to set up the workspace. I'll put all the items I create during this in the same resource group. That makes cleanup easier when I'm finished. That's done. Let's go to the portal and take a look. Go into Log Analytic Workspaces, and there it is. That script created a new Log Analytics workspace. Now that we have that, the next thing is to create the Azure Automation account. The next step is to download the script that will create the account and runbook. This block of code creates a temp directory on the C drive and downloads the PowerShell script. Let's give it a run. It also moved us to that temp directory. That looks like it downloaded the script we need. Next step is the parameters. With this, we're using splatting in PowerShell to populate a hash table with the parameters that are passed to the script. The script uses the parameters to create an Azure Automation account and the runbook that does the work of starting and stopping VMs. The next thing we'll do is fill out the parameter block for the script to use. This information includes the Azure AD tenant ID, the subscription AD. It uses the ARM API. We enter the resource group name that the Azure Automation account will go to, as well as the actual name of the Azure Automation account. We also have to add the location. I'm also giving it the name of the Log Analytics workspace we just set up. All this code came from the Microsoft documentation. Notice that there's comments in here that you can leave some of these off, and it'll use default values. Run the parameters block to add that to memory. I did that already, and you can probably tell that I modified some of my IDs just for this presentation. Once you have that in memory, the next thing we'll do is run the command. So this is going to run the PowerShell script and pass in the parameters value. This is going to take a few minutes to run. It has to set up the account and import the AZ modules into Azure Automation. That's finished, and it didn't take too long thanks to the miracle of editing. Notice that I'll put a few different pieces of information down here. There are two pieces of information that we'll need in an upcoming step. One is the Log Analytics Workspace ID, and the other is the Log Analytics primary key. These are essentially credentials so our automation account can write data to Log Analytics. Let's go in and take a look at our Azure Automation account and runbook. Here we are back at the portal. We'll go into Automation Accounts, and here's the WVD Autoscale Automation account. There's a lot of stuff in here. We're going to first take a look at the runbooks. And here's the runbook that was created during the deployment. You can go in and take a look at it. You can go into View. If you want to read through it and see what it's doing, that's all available. Eventually, we'll pass parameters into this runbook using Logic App. But before we can do that, we need to create a Run As account in Azure Automation. To do that, we're going to go back to the Automation account and go down to Account Settings and Run As account. A Run As account provides authentication to the runbook for accessing the Azure subscription. It's made up of a service principal and Azure AD with contributor rights to the subscription. From the Run As account page, click Azure Run As account, not the classic one, the non-classic one, and we'll click Create. That'll take a minute or two to finish, and there it is. So let's go into this account. And here you can't see details because I have them blurred out, but trust me, they're there. The one thing I want to point out though is this certificate. It expires in a year. Once this expires, it will quit working. So you might want to make a note of that. You can simply renew the certificate if you want to create a new one. This probably could be done all within an Azure Automation account, not using a Logic App, except for one thing. If we go back to our Automation account, if we go to Scheduled under Shared Resources, we're going to add a schedule, and I don't need to add a name. I'm just going to hit Reoccurring, and notice that recur every hour, day, week, or month. The minimum reoccurrence for an Azure automation schedule is 1 hour. Odds are you'll need something more frequent than hourly to dynamically start and stop these session hosts. Imagine the amount of users that typically log in between 8 and 9 during a business day. Logic apps can be scheduled to run more frequently than 1 hour. That's one of the reasons why this solution uses logic apps to trigger the runbook. Let's go back to VS Code and set up the logic app. This is similar to the Azure Automation setup process. We'll download the deployment script, then fill in a bunch of variables, and then we'll splat that into the deployment script at runtime. And again, all this code is available on the Windows Virtual Desktop documentation site. So we'll just run that. This will create a folder and we can take a look at what's in there. It has our create or update AZ automation account script and the new create or update AZ logic app script. This next section needs a little explanation. I commented out the original version. I had to do this a few times, so I removed this interactive nature from it. If you run the code that's available, it will just prompt you to enter in things like the Log Analytics Workspace ID, Log Analytics primary key. That came as output from one of the previous commands. But again, I had to do this a few times, so I commented that out and I copied it down. And I just created hard-coded answers so I could run this multiple times without having to go through that interactive process. But either way you do it, it's going to gather a tenant ID and your subscription information, the resource group that you're using, as well as the Windows Virtual Desktop host pool. Once it has that, it'll ask for information, the Log Analytics Workspace ID and primary key. We already went over that. The reoccurrence, start and end of peak time, the time difference. This is -6 where I'm at. Note, this won't take daylight savings time into account. The threshold per CPU. In my example, I use a low value of 1. Each session host has 2 CPUs, so each session host can have a total of 2 sessions before a new session host is turned on. I did that to limit the number of times I have to log in during this demo before a new session host is started. There should always be a minimum number of session hosts available. In this case, the number is set to 1. For maintenance tag name, if a server has a tag set with a value you specify here, it'll be considered in maintenance mode and gets ignored when the runbook runs. The limit seconds to force log off user is set to 0. So with it set to 0, it won't force any users to log off. It instead relies on the admin setting a group policy object, forcing idle and long-running sessions to disconnect. You can set a value here to force user log off if you'd like. I'm doing that through a GPO instead. And if you do have that set to something other than 0, the log off message title and log off message body will display when a user is forced to log off. And these last 3 lines collect information about the Azure Automation account. Next, we'll build a hash table that will splat into the deployment script at runtime. This is all about formatting. It looks much better this way compared to passing the parameters as part of the command to run the script. Let's add that to memory. Now that we have all that together, let's run the deployment script and pass those parameters in. All right, that's done. Let's go back to the portal and take a look. Let's go into the logic app we just created. Note one thing right away, it ran once already, so that's a good sign. We can see that it succeeded. Next, let's go to Logic App Designer. If you've ever used Flow, this will look familiar. Logic App is an enterprise version of Flow. It's billed by runtime, not dependent on an O365 license. Anyway, click on each of these boxes and we'll see what's happening. If we go into resources, we can see that the interval is 15 and the frequency is minutes. So we can trigger this to run down to seconds. One thing to be cautious about, it takes a few minutes between when a session host is started until it shows as available in Windows Virtual Desktop. So if you set this interval too low, it may continuously start more VMs than you would want because it doesn't see that a VM that it's already started has registered to Windows Virtual Desktop yet. Now if we go to HTTP, this is the content of the webhook. It does a post to the Azure Automation Runbook webhook URI. In the body is the parameters that we passed in when we set this up. This information is consumed by the Azure Automation account at runtime. It uses the Run As account to get and change settings in the host pool, such as the number of logged in users and the number of VMs that should be running. So we'll discard. We don't want to save any changes. So to understand what happened is this resource was triggered and it sent all the variables we set up to the Azure Automation Runbook using a webhook. So if we go to Azure Automation, we'll go into our automation account, and you can see we have one job completed. And we can go into jobs and take a look at the details. So here's the webhook data that was passed in. We saw this in the HTML section of the Logic app. And if we look at output, it's going to show us the parameters it used. And if we scroll down, it's telling us the number of session hosts in the pool, what the time is. It lets us know that we are in peak time. Then it gets all the VMs and checks the session host status. And it lists through each of the session hosts with their current status. The number of session hosts running is 0 out of 4. This is giving us details about the job when it ran. Here's what I want to point out. Right here is where it indicated that it was starting the session host wvd demo sh-3. Although no users were logged in, we specified that at least one VM should be running all the time. This script saw that and it powered up the VM. So that's working exactly like it should. Next, let's see what happens when we log some users into the pool. After setting this up, I signed into Windows Virtual Desktop with a few users during peak time and after hours to generate some messages in Log Analytics. It would be tedious to walk through that process in this demo. Just trust me, I went through the process and it all worked as expected. But you don't have to take my word for it. Let's take a look at the data sent to Log Analytics from the autoscale script. Here I am in Log Analytics, and I am going to make a little room here. We'll just collapse these menus. And I have all these queries saved. We'll close that out. I modified some of the Log Analytics queries available from the Solutions page. This first one returns all the logs from the past 24 hours. So we can just highlight any place in here and click Run. And that returned, it looks like 17 pages. So let's filter this down a little bit. Let's go to all the logs related to session hosts. So I'll run that. And just so we can get a better view, I'm going to collapse that menu as well. We'll run it again. Here we can see the name of the session host, the power state, and if it's available or unavailable. That's some good information, but let's filter this down to some more specific information. The next query looks for records of the VM starting and stopping, and the corresponding message that indicates why. And before I go any further, I'm going to change this display time to local time. There we go. So now the timestamps are all set to local time. So if we look at 6:52, we can see that we're off peak. And the number of running session hosts is greater than the minimum required. It needs to stop one VM. And the next line right above it is it stopped a VM. But before that, we can see at 3:20, it was in peak time and the number of user sessions per core was more than the threshold. So it needed to start one core or one server. We can't start a fraction of a server, at least not yet. So if it needs another core, it needs to start an entire VM. And that's what it did in the next line. And keep in mind, this is sorted in descending order. With the next query, we can filter down to just start and stop actions. The results from that query list all the start and stop actions and the session host those actions were applied to. If we scroll down, the next query will get the number of running session hosts and the number of users. Here we can see that the last time it ran, the number of running session hosts was 1 out of 4, and the number of sessions was 3. And if we scroll down some more, this query finds all of the logs that contain error or warning. So we can run that. If we expand this down, we can see that this is a warning indicating that there's not enough session hosts to start, which could be a problem. I created this error by putting all but one session host in drain mode and signed into Windows Virtual Desktop with multiple accounts. In production, this may mean that there's a surge in usage and it's getting close to overrunning the session host. The last query is just filtering down to that message, not enough session hosts to start. And here you can see it happen twice. This would be a good message to get alerting on. We can create alerts right from this interface with the New Alert Rule button. Let's create a rule now. Click on New Rule Alert. Under Scope, the rule is set to the Log Analytics Workspace we set up. In Conditions, click on the condition name. This is where we'll modify the condition logic. Let's take a look at the search query. Notice it has some formatting that's not needed for this condition. We can remove the project and the sort by logic. Scroll down to Alert Logic. We want this to trigger when the results are more than 0. So under threshold value, enter 0. Scroll down to Time Period. Here we'll set the time frame the query will use. For this event, set it to check over the past 5 minutes. For frequency, set it to run every 5 minutes. So every 5 minutes, it will look back over the past 5 minutes and trigger if the result is greater than 0. Click Done when finished. Notice it gives us an estimate of how much this alert will cost. Next, go to Action Group. This is where we define where the alert will go. Click Select Action Group. I have a few in here already. Let's create a new one. Set the subscription in the resource group. Give the action group a name and a display name. You don't need to create an action group each time you create a rule. As you may have noticed from the last screen, once an action group is defined, you can reuse it for other alerts. Now we set the notifications. We have a couple options. If you select Email Azure Resource Manager role, you can set the rule to email members of specific Azure roles. Change it to Email SMS Message Push Voice. From here we can set an email address, an SMS address, a push notification, or voice. Select Email and add a valid email address. Click OK when finished. Give the notification a name. Notice you can add multiple notification types if you need more than one. Next, go to Actions. Under Actions, you can set the action group to do more than just send email. It can trigger Azure Runbooks, functions, logic apps, or trigger a webhook. Leave that blank and go to Review and Create. And Create. Now that the action group is added, we could customize the subject and add JSON data if needed. At the bottom, give the alert a name. Add a description if you'd like. We'll leave the resource group as is and change this to a Sev1. We'll enable the alert rule upon creation and leave suppress alerts blank and click Create Rule. That's done. Let's go back to Log Analytics. If you need to view or modify the alert rule, go to the Workspace and Alerts under Monitoring. Here you can see the history of the alerts. There is a Sev1 triggered for this alert. This was the same alert under a different name, but we can see details of that alert. Go to Manage Alert Rules. Here we can modify the alert we set up. You can also go to Manage Actions and modify any of the action groups that you've created. That is how you set up and manage alert rules in Log Analytics. That's a lot of information, and if you're not used to Custo Query Language or KQL, it could seem intimidating. It's really easy to learn, and Pluralsight has a course called KQL from Scratch that's free and a great spot to start learning. Searching logs is fun, or at least I think so, but graphs are better. Let's move on to using Log Analytics to monitor the Windows Virtual Desktop service. This is great. The ability to start and stop session hosts based on demand keeps costs down while providing a high level of service to the end users. That's what moving to the cloud is about. Service monitoring is another important element of maintaining a healthy Windows Virtual Desktop environment. This is simple in Azure with Log Analytics. The information we're going over is based on a blog post by Christiane Brinkoff. It provides the steps to enable Windows Virtual Desktop monitoring in Log Analytics. It also provides a template workbook of charts and graphs to display the information. This solution uses Log Analytics as well, but it adds some data sources. Let's start with Azure Diagnostic Settings. Each Azure platform has a set of logs that provides auditing and activity details. With Azure Diagnostic Settings, those logs can be sent to Event Hub, an Azure storage account, or Log Analytics. This solution configures the Windows Virtual Desktop services to send logs to the Log Analytics Workspace we set up previously. We also send sign-in activity from Azure AD to Log Analytics. Sign-in activity is only available if Azure AD Premium P1 or P2 is in place. This step can be skipped if you don't have Azure AD Premium. There's a heat map that won't show data, but the rest of the solution will work fine. The solution needs to gather performance information from the session host, things like CPU, disk, and memory utilization. This is gathered with the Log Analytics agent, a small agent installed on the computer used to send log data to Log Analytics. Once all the sources are sending data to Log Analytics, we can import the workbook and provide a visual representation of the data. Let's deploy the solution, starting with installing the Log Analytics agent and configuring Log Analytics to collect performance data. To get things started, we need to get data from the session host VMs. We can do this by adding the Workspace agent to the VM. This is easy to do with an Azure virtual machine. Simply go to the Log Analytics Workspace, scroll down to Workspace Data Sources, select Virtual Machine, click on each of our session hosts, and click Connect. We'll do this for each one. Now they show connecting. This will take a couple minutes to finish. This only needs to be done once when you're onboarding the solution. Now that we have the servers connected to Log Analytics, we need to configure Log Analytics to collect the relevant data. By default, Log Analytics won't collect performance data. We have to tell it what to collect. So let's take a look at what's required for the solution from the Tech Community article. If we scroll down, under Collect Performance Counters, it outlines all the performance counters we need to add. So I'm going to select this first one. The first item is the Terminal Services Session % Processor Time. To add that, let's go back to the Workspace. Go to Advanced Settings. That's located under Settings. Then we go to Data and Windows Performance Counters. Now I can paste that counter in and then add it, and then switch this to 60 seconds. You can sample more frequently, like 10 seconds, but Log Analytics is built based on data usage, and there's really no need to add more data and cost than necessary. We need to do this to all 36 of the counters listed on that page. I'm not going to force anyone to watch me do that. And matter of fact, to speed things up, I created a PowerShell script that will add them for us. Let's take a look at that. Here I am in VS Code. The script needs our Log Analytics Workspace resource group and workspace name. I have that entered in here under variables. After that, it builds a list of the performance counters from the Tech Community post. The script then loops through each, does some formatting, and adds the counters to the workspace. This script is available on my GitHub page, or you can find a link to it from my blog. I'll make sure I'm still logged in. Yep. Let me switch directories quick. There we are. Now let's run the script. It'll take a minute to loop through all 36 of these. That finished. Now let's go back to the portal and take a look. Let's do a refresh. Go into Data, Windows Performance Counters, and there are all of our performance counters. Next, we need to add the Azure AD sign-in logs. Do this by going to Azure AD and Diagnostic Settings. Diagnostic Settings is located under Monitoring, and we'll add Diagnostic Settings. Start by giving it a name. I'll use AAD Diagnostics for this example. Select Sign-in Logs. Notice the note about sign-in logs requiring Azure AD Premium P1 or P2. If you don't have Azure AD Premium, that's okay. There's a heat map on the solution that won't work, but everything else will work fine. You can skip this step if you don't have Azure AD Premium. Once you have sign-in logs selected, go to Destination Details and Send to Log Analytics. Select the workspace you want to send this to, and once finished, click Save. Next, we'll do a similar process with Windows Virtual Desktop diagnostic data. We're going to go into Windows Virtual Desktop, go to our host pool, select the host pool we're going to monitor, and Diagnostic Settings. We'll add Diagnostic Settings, give it a name, WVD Demo Host Pool -Diagnostics for this example, and then we'll check all logs, and we'll send to Log Analytics, make sure that the correct workspace is selected, and then click Save. We'll repeat this process for Application Group and Workspace. We'll go to Application Group, select our Application Group, Diagnostic Settings, Add, we'll give it a name, WVD Demo AG-Diagnostics for this example, select all logs, then we'll send to, and then select our workspace. And we'll do this one more time. Go to Workspaces, select our workspace, Diagnostic Settings, and go to Add Diagnostic Settings. We'll give it a name, WVD Demo WS-Diagnostics for this example, select all logs, we'll send that data to Log Analytics and make sure our correct workspace is selected. And this too only needs to be done once. Now that we're sending all the data to Log Analytics, we can add the workbook to visualize the data. Start by going back to that Tech Community page, and under Creating a Workbook in Azure Monitor, find the link to the GitHub page with the workbook code. That's right here in step 4. We'll need this code for our new workbook in a minute. Click on Raw. That just makes it easier to copy and paste. So if I do a select all and then copy. Now let's go back to the portal. Go into Log Analytic Workspaces. Select our workspace. And go to Workbooks. We're going to add a new workbook, but let me collapse this. There. Click on the code icon. We'll Control A and get all this out of here. Next, I'll paste the code from GitHub into the workbook. Once that's in there, click Apply. And before we finish editing, select the Log Analytics Workspace. And then make sure that the resource group and the host pool are correct, and that WVD host is set to all. Click Done Editing. Save. We can give it a name. And then click Save. We just started collecting data, so there's not much to view yet. Let's give it some time to collect more data for us to view. Some time went by and we now have data to view. I logged in with a couple accounts to create this data. Let's go into our Log Analytics Workspace. We'll go to Workbooks and click on the workbook we just created. There it is. I'm going to make some room on the screen. There we go. The overview page gives us, well, an overview. Most of this is self-explanatory. There's an overview of Windows Virtual Desktop resources. You can see I have one host pool and one application group. There's also a connection count and current session status. The login location heat map requires the Azure AD sign-in logs and Azure AD Premium P1 or P2 license. If you don't have the premium license, that's fine. It just won't show up. You can remove it from there if you'd like, or just ignore it. I used a VPN to sign my test users in from different locations across the globe. Coincidentally, that's also a good way to test risk detection in Azure AD Identity Protection. If we scroll down a little bit, we can also see current sessions and top users. That gives us a pretty good overview. We can drill down into session details. Here, there's a series of top 5 items, including host with connected sessions, active users, and top sessions by host. We also get an overview of the operating systems, and if connecting with a web browser, details on what version they're using. Next is session diagnostics. And here we can see we have one error. One or more errors occurred with a WebSocket. This issue was actually caused by a stress test that I'm running on one of the session hosts. Under user-specific reporting, we can come to username and enter a username. We can see an overview of the user sessions. We also get some details about the user's connection activity. Under session performance, that gives us an overview of all user sessions. We get some good details on process and disk performance. Here it shows the % user time by process. Heavy load is the application I'm using to stress test. That's why we see that high value. We also get some disk I/O read and write operations. Some more good information to have on your session host. While session performance gives us details on user sessions, host performance breaks down that data by host. Host performance gives us details about each session host. We have a grid of different performance counters per session host in Host Performance Overview. If we scroll down, you can see that there's one session host with a high CPU condition. I started a CPU stress test on this to get something interesting in return. It also gives us % of free disk space. And if we scroll down a little further, we can get some key metrics here: logical disk space, % processor time, memory committed bytes in use, and network usage per host. If we scroll down a little further, we also have round-trip latency by computer and by session. Let's move on to disk performance. At the top, we have performance counters broken down by session host with line graphs. And if we scroll down, we can see where I crashed the server. If we want to remove or add additional counters, we can come here and unselect one, and we'll select current disk queue length. This gives us details on the queue length for each session host. This solution provides a wealth of data out of the box. All we see here comes from log analytics. It's also possible to run queries against the data like we did with the auto start and stop script. You can also create and modify the graphs in this runbook with that data. That brings us to the end. I hope you found this information helpful. Scripts I used in this presentation can be found on my GitHub page. You can find other Azure and Windows virtual desktop information on my blog and YouTube channel. Thanks for joining me.